Okay, here's some help for homework 25. Question 1. You'll notice in the question it talks about the rate of the leak. Well, that means V dashed. So we have this formula which says V dashed equals 8 minus T. And we are asked to find out what V is worth. So how do you go from V dash to V? We integrate. Now once we've integrated, we're going to end up with a plus C. How do we find the value of C? We put in the initial conditions. And the initial conditions are that the volume lost is 50 when T equals 8. So if you plug these back into that formula, then you can work out what the value of C is. Question 2. Let's rewrite this as a single log. So that half at the front goes up to be a power, and we don't have anything else which is at the front. So it becomes log to the base 3 of 81 to the power of half. Now I'm just going to write that as square root. The next one's an add, so that's going to be times 15. The next one's a take away, so that's going to be divide 25. And the next one's an add, so that's going to be times 5 again. So if you work out what the top is, work out what the bottom is, you should be able to solve it. Question 3, we've got a circle, x squared plus y squared equals 10. We know that that is a circle which is centred on 0, 0. And we're asked to find the equation of the tangent at 1, negative 3. So we're asked for this line here. So how do we find the equation of a tangent? We go through the stages of, first of all, finding the gradient of the radius. So that's using the 0, 0 and the 1 minus 3. Then we find the gradient of the tangent. And then we use the point 1 minus 3 and that gradient, and the y minus b equals mx minus a. And you should get the answer, which remember was changed to x equals 3y plus 10. For the second part of the question, show the tangent is also a tangent to the circle. Well, we take the x equals 3y plus 10 and we substitute it into the formula for the second circle. So every place there's an x, we're going to put 3y plus 10. So the 3y plus 10 is going to go in here, it's going to go in here. Then when you solve that, you should end up with equal roots if it's a tangent. So you should end up with one answer. That answer will give you the other point of contact, and then you just use the distance formula to work out the distance between A and B. Okay, here we go, question 4. The question tells us that f0 is 100, that f is 80 when t is 0.2. So we can plug each of these numbers into that formula. So that gives us 100 e to the negative 0.5 times that lambda symbol times 2 is equal to 80. Now if I tidy this up a wee bit, so take the 100 off this side over here, then it becomes 80 over 100, which is 0.8. And if I then multiply the negative 0.5 with the 2, I end up with e to the negative lambda. If I take the opposite of e to the power as log, I get negative lambda as log 0.8, and then lambda, the missing thing, is equal to negative of log 0.8, which you can get from your calculator. Now for the second part, how long does it take the clown to become half as funny? Remember, we've worked out this symbol, this lambda thing previously. Okay, if we're trying to work out when it takes half as funny, then I just need to take this part of the formula. Okay, I'm not interested in the first two bits, they're irrelevant. Just this part of the formula, the e to the negative 0.5 times, you've worked that out, times t is equal to 0.5. And then you just proceed like you did earlier. take the logs of each side, and you should be able to work out what t is. Question 5, solve that equation. We need to take the cos and the sine and make it into a single trig function. And the single trig function I want to make it into is k cos x minus alpha. So go through your procedure of cos theta plus sine theta equals k cos x minus alpha. Work out what k is. I'm going to tell you it's root 2. Work out what alpha is. I'm going to tell you it's 45 degrees, or in the context of this question, pi upon 4. So you've now got root 2 cos x minus pi upon 4 is equal to 1. If you now take the root 2 over, work out the cos, and then deal with the angle. Solve the little equation that you get. Now question 6. Looks like a lot of stuff to do, and it is. Given that x minus 1 is a factor, so the first thing you're going to do is your synthetic division with 1 here, 1, 0 x squareds minus k x's and 2. Okay, you're going to work that through to work out what k is equal to. Okay, for part B, you're then going to factorise it. So you're going to end up with 1, 2, 3 brackets. Part C, find the stationary points. Go back to your original expression, your f of x equals x cubed. Okay, I'm going to tell you, just to help my writing out the solutions, that k is 3, so you get minus 3x plus 2. So for the stationary points, we differentiate that. We put it equal to 0. We do either our nature table or we do the second differential method, and that tells us what the stationary points are. Then for part D, we take all that information that we had earlier and we draw the graph. Then we have to find the points of intersection between the graph and the line. Okay, I'm going to give a wee bit extra help. Your curve should look something like this, and the straight line y equals x add 2 should look something like that. So what we're trying to find is where these points are that the curve and the straight line intersect. So we take your curve, which was x cubed minus 3x plus 2, and we put that equal to x add 2. Take everything over to this side, factorise, solve, you'll get 3 answers: x equals, x equals, x equals. Now these answers for the x equals, they are for these points here where the curve intersect. So to work out the last bit of the question, we're going to do the area between the first two of the top curve, which if you're looking at it up here, the top curve is the orange one. So that's your quadratic formula, x cubed minus 3x plus 2, take away your line. And then you're going to repeat it for the blue area. So that's going to be the integral between these points. The straight line is x add 2, and then take away the curve, work all that out. It's quite a lot of working, but you'll enjoy it.